Well, it's thrilling to be here tonight. We have an amazing panel lined up, and a little more on my background. Shasta hasn't been around for 20 years, but I have been investing in venture capital for about 22 years now. Co-founded Shasta about 13 years ago. And over the last 5 years, have been looking a lot on behalf of the firm at what we call emerging platforms. So what is coming after the smartphone? And we think one of the key waves there is robotics. We spend a lot of time in robotics. It's an area we're very interested in. It's also a very challenging area as a startup or as an investor to make money because there's a capital intensity that's there. And then obviously, when you think about an autonomous vehicle is a robot. It's all about robotics. And over the last few years, you've seen these trends come together, whether it's perception, whether it's identification of things, whether it's computation for path planning, mapping, the internet. All these things have come together to enable robotics that can autonomously navigate around the real world that we live in. And I'm sure everybody in this room can remember the first time they saw an autonomous vehicle. All of us here in the Bay Area remember seeing those cars that at first we thought were mapping vehicles, and they had the spinning trash can on the roof. And those were the autonomous vehicles that we all remember seeing. Sterling has co-founded a company with somebody that helped create those vehicles, Chris Urmson, and Sterling will share a little bit about the creation of Aurora. So we're here tonight very specifically to talk about fully autonomous vehicles. And these are the vehicles that we think of for those of us that remember the Jetsons or remember these ideas that cars where you could just put in information about where you want to go and the vehicle would get you to where you want to go. And that's what we're here to talk about tonight. And when you look at fully autonomous vehicles and you think about the big question is, when will we get a fully autonomous vehicle? When will you get that vehicle that you can get into, say the destination, and whether it's snowing, sleet, daytime, there's a lot of construction, it gets you to where you want to go. And there's really three major questions around when that happens. One is the pure technology piece, the sensors, the computation, the maps, the things that you need to control the car, actuation, et cetera, really the technology building blocks. And we'll talk about that a bit tonight with this panel. The second piece is, when do we know that it's actually safe enough for us to ride in these vehicles? And how many nines of reliability does that take? How many times could you actually have a failure at some point along the way? And in a lot of ways, that's one of the biggest questions that we face today. And there are questions around, how do you simulate it? How do you do enough miles? How many miles do you actually have to travel without a disconnect of the autopilot or of the autonomous system to know that it's safe enough? And is that even possible to be done? That's the second thing we'll be talking about. And the third one we'll touch on is regulation and standards. And what is the role of government in terms of saying, OK, these vehicles are ready? Because I think there's no question in people's minds that these vehicles eventually will be far safer than human drivers. And to get there, what is the role of regulation in doing that, in making that possible? So to level set before we get into this, just a quick show of hands, how many people are familiar with the layers of autonomy? Just raise your hand. OK. So I'm going to go through for the people that aren't and just make sure that people understand what are these levels of autonomy. And then what we'll do is Sterling will walk through the story of Aurora and set the stage for what's going on in the technology today. I'll introduce the panelists. In fact, I'll go through and introduce the panelists right now. We have Sterling Anderson, who is a co-founder of Aurora, has a PhD in robotics from MIT, and was also head of the autopilot program at Tesla. We have Ivan Mihov, who is a product manager, I believe, or program manager at Zoox now, formerly worked on business development for Zoox. Zoox is a very highly funded, very, maybe not high profile, but well-known, fully autonomous vehicle company. Then we have the incumbent. I love calling Lyft an incumbent, with Vinay Shet, who is a director of product at Lyft, and he may or may not share some of the details of what they're working on. And then we have Alexei down the road here, who is at Autotech Ventures and is focused on investing in the space. So before I turn it over to Sterling, I'm going to go through these layers of autonomy, and this is how it's defined by the Society of Automotive Engineers, and I'm sure Sterling will correct me if I make some mistakes here.
I will.
Level 0 is my favorite level. I love to race cars that have level 0, and this is the system capability there is none. That's what the 0 is for. Level 1 is what I think many of us were familiar with when you start to think about cruise control and things like that, where the car controls either steering, vehicle speed, but not both simultaneously. It's under certain conditions. Level 2 is partial automation. And the way that people talk about this is it's a car that can steer, accelerate, and brake under certain circumstances. And when you look at Audi's traffic jam assist, Cadillac Super Cruise, the Mercedes-Benz driver assistance system, the Tesla Autopilot, and Volvo Pilot Assist, that's kind of the state of the art. Where we are right now, these are things that you can commercially buy in cars. So it's this crossover between level 2 and level 3, let alone level 4 and level 5, where you have, in the right conditions, a car can manage most aspects of driving, including monitoring the environment. And that's the critical changeover that we all will see in cars when we start to drive them. That's the difference between level 2 and level 3. And then in level 3, it'll prompt the driver to take over if it sees something it can't navigate. That's the big change that we're looking at. The one that we'll be talking about tonight is how do you get to level 4 and level 5? And level 4 is where you can operate without human oversight. And this is where you start to talk about cars that might not have a steering wheel inside. And it's still under certain conditions. Maybe it's in a campus environment, an urban environment, et cetera. The final one is full automation. This is level 5. This is the one where you get in the car, the one we all dream of. You stumble out of the bar, you get in the car. There's no steering wheel, so you can't get a DUI, and you tell the car where you want to go. So with that, would like to hand it over to Sterling, our featured panelist, to talk a bit about maybe talk a bit about Aurora and just your views on the environment, and then we'll jump into some questions.
Sure. Sure. Hello, I'm Sterling Anderson. Rob has asked me to, I think before this, to talk a little bit about how Aurora came into being, a little bit about the journey. So I'll spend maybe a couple of minutes on that, and then we can get to the questions, which is, I think, where some of the more interesting content will come up. A little bit about Aurora and sort of its origins. It started, a lot of the pieces that have come together to form Aurora really started about a decade ago for me. So in 2006, my little brother was hit by a car traveling about 40 miles an hour and broke his neck. That was a transformative time for me. I was just deciding sort of what I wanted to do with what I would do next. It led me ultimately to MIT, where I spent several years developing what became known as the Intelligent Copilot. It's a system I developed with Carl Yaniema, Emilio Fasoli, John Leonard to improve the safety of sort of our roadways in a substantial way. At that time, I think mindsets around self-driving have really shifted since that time. This was in the 2007 days. This was sort of the days of the DARPA Urban Challenge. Autonomy, self-driving were viewed as a plaything of the Department of Defense, but not necessarily something that would transform or change the industry as we know it. That's really changed in the last 10 years. It's been a really fun change to observe, right? At that time, shared vehicles were also viewed as not really a thing, right? I had a CEO of an automotive company, and as late as I think it was 2014, tell me, ride sharing is stupid. Would you share your house? Then why would you share your car? This was kind of the prevailing mindset. And it's been fun to see this confluence of self-driving development, which has really been spurred on by recent developments in both hardware and software. Specifically, the revolution of applied machine learning that started 20 years ago has really accelerated since about 2014 with the advent of some computational neural networks and their application to more than just the computer vision problem, but much more than that throughout the self-driving software stack. Beyond that, there have been developments in the shared vehicle space, specifically with Uber, Didi, Lyft, some of the incredible things that companies now known as incumbents have been doing in this space have really incubated an environment wherein the benefits of self-driving, specifically as it applies to shared vehicles, can really be sort of brought to bear, brought to society. So I co-founded Aurora in early 2017 is when we got started. My co-founders are Chris Urmson, who, as Rob mentioned, was the head of Google's self-driving program and built that program for many years. Drew Bagnell, who is a founder of Uber's self-driving program. And with Aurora, we wanted to pull together a bit of a strong team that could go at this with a sort of build V2 of what a self-driving system looks like. V2 in a couple of senses, and I'll explain two of the sort of guiding principles, one around the technology and one around the business strategy that really guided how we approach this. First, around the technology, there's a quote from a gentleman by the name of Larry Jackal back in the sort of Bell Lab days, where he mentioned, don't try to build a ladder to the moon, right? Where ladder to the moon was a proverbial reference to the tendency in engineering to add incrementally to what we know and build things that one can observe a day-by-day improvement in, right? This is exciting, it's rewarding, and is gratifying for both engineers and investors as they work on very difficult problems. The challenge is ladders never get to the moon practically. This approach to incremental development, this approach to building on the solutions that we know, tends to be rather flawed. And so one of the philosophies that we took technologically was don't build a ladder, build a rocket ship. And what that will mean is that you will spend significant amounts of time with the ship on the pad as you're building the engines, as you're fueling the ship. But ultimately, traversing that 250,000 miles to the moon will be much, much more rapid once that rocket takes off. And so building a team that has the experience of understanding what the pitfalls are of this space, who has an understanding of the architectures and the specific approaches with regards to the application of machine learning throughout the stack in intelligent ways that are at once both rapidly learnable but also verifiable, which is one of the key challenges of doing this right, was important to us. So that philosophy of building a rocket ship rather than ladders to the moon was important and led us to do things a little bit differently than I think a lot of the rest of the industry has. We've eschewed demoware. You've probably seen nothing from us in terms of videos of cars driving. That's intentional. We're not developing those demos. We're not looking to, and no offense, to excite the likes of Rob about sort of the incremental progress in the technology. We're looking to build for the long term, and so we've sort of focused on that. The other principle that guided the foundation of Aurora was this idea that we don't need to be disruptive to build value, right? And disruption, as Clayton Christensen coined it many years ago, is, I think, a very valuable principle and something that's been, I think, used to great effect in many industries. But in this one, we saw this as a blank slate opportunity where we could actually be a catalyst in many ways. We could be constructive rather than destructive. There are a number of different players and expertises that have to come together to solve a society-changing problem that is self-driving. There's the vehicle, right? And a number of existing players who have spent decades, in some cases nearly a century, honing and refining this magic that is building a system that is more complex than I think many of us appreciate and rolls off an assembly line every 2 minutes and lasts for 15 years in extremely challenging environments. This is nothing short of a feat of industry over the last decades. We saw an opportunity to work with, rather than in competition with a lot of this industry, to work with the OEMs who bring their expertise in building vehicles, to working with ride-sharing companies who are much more than just an app. What Lyft has built, what Didi has built, what Uber has built is an incredibly advanced stack of machine learning intelligence around how do people move, how do we predict the appropriate, not only the appropriate routes, but the time to destination. And so that on the business strategy side, Aurora was an opportunity for us to let everyone play their position. We believe we have some of the best talent that has approached the self-driving world for the last decade. We've built, and not just Chris, Drew, and I, there's a lot of people in our team that have done some phenomenal things in the self-driving world and understand the lessons of that. But between that and an approach wherein we focus on specifically what we're good at and let others do the same, and work in partnership with the automotive community, with the transportation network community, with others that have to come together to realize this. My hope is that we can benefit the world in a substantial way, reducing accidents of the kind that broke my little brother's neck, improving the efficiency of transportation, giving back the land in some of our most precious land in cities that is currently used to house vehicles that are used 5% of the time, to instead parks and office buildings and your garages into studios and bedrooms. And so this was kind of the vision of Aurora, and it's a bit of a culmination of several careers or life's work in bringing this about.
So I have one quick question for you. Can you frame how big Aurora is, or the types of people you're looking for, to at least get that perspective?
Sure. Yeah, we try to build Aurora out of from a combination of engineering expertise, engineering excellence, and machine learning experience. So specifically, we try to pair arm in arm some of the world's best engineers with some world-class practitioners in some of the arts of applied machine learning and self-driving technologies. So we're a very engineering-driven company, as you might imagine.
Are you hiring?
We are hiring.
Okay.
In fact,
and where would people go?
I think we've doubled in the last, I've got a couple of my recruiters here, we've doubled in the last maybe 6 months. We'll double again by the end of the year.
Okay.
Our offices are in Pittsburgh, one in Palo Alto, and one in San Francisco.
Okay.
We have fleets operating on the roads in all 3 locations. You'll hear about a few other fleets in other parts of the world before too long. It's an exciting time.
Okay. Well, let's go ahead and jump in, unless there's anything else you'd like to add at this point. I would love to jump into this question that everybody has around when do we get the fully autonomous vehicle? And I think everybody in here, I'll just assume everybody in here has seen autonomous vehicles on the streets of the Bay Area. So I want to get a sense, I want to build a bell curve together with this entire audience right now. Just raise your hand if you think a fully autonomous vehicle is more than 1 year out. I mean, it's pretty much everybody, raise your hand. So we're going to, no, keep it up. So we're going to build this quick bell curve. Lower your hand if you think that we're going to get to a fully autonomous vehicle. And the way I'm going to define it for the purposes of this is you can get into a ride-sharing, ride-hailing vehicle and put in your destination, and it'll take you where you want to go on good weather here in the Bay Area, anywhere in the Bay Area. Do you see it in the next 3 years? Okay? The next 5 years? The next 7 years? Okay, I would say probably about that time frame for myself. Next 10 years. Okay, and that looks like that's everybody. Okay, so it sounds like the average that people expect in here is probably about 5 years. Is that what you guys read out of this, or would you say 3 or 4? From the audience, what do you guys think the audience just told us?
5-ish.
Yeah. About 5-ish years, you'll get that full autonomy. So maybe just jumping in, because you have one of the leading ride-hailing networks that's out there right now. What's your view of how long until people in this room can do this? Would you agree with the over-under that people have here?
Yeah, so I think the way you position this saying full autonomy, I think that's we've got to be careful how we use that word. I think what is, from Lyft's perspective, our ambition is to build a product that services people, that builds the best transportation network possible. What people really care about is when they call a Lyft, the car gets there within a few minutes.
Is everybody able to hear Vinay, by the way?
No? Okay, all right. So what our users care about when they hail a Lyft is that the car gets there within a few minutes and gets them to where they want to get to in time. It's not, I don't think it matters as much whether the car that comes to you is driven by a human or it's driven by a robot. That's point number one. The second point is that, in principle, we could deploy a robot within a very specific area because we fully understand the start and the end of the ride before the ride even happens. Right? So it's less about getting into this world where we live in a world of full autonomy. It's more about getting step by step into a world where we're able to deploy this technology meaningfully to deliver a real product to our users to meet their user needs.
Well, does that mean when you're thinking about your app, you would actually start to insert in routes that you could serve well with full autonomy versus ones you might not serve as well?
Potentially. I mean, I think as we talk more about this evening, we'll talk about different terminology, but there's one aspect where you can characterize, for instance, what a particular technology can handle in terms of the domain that it operates in. And if we know the start and the end of the ride before it happens, we have a better handle of what that domain looks like. If your car can handle sunny weather, in light traffic conditions, for instance, that's one way to characterize it. And if you cannot handle rainy weather, for instance, that's another point of view of saying don't drive in that situation. So being able to deploy in such a situation already provides us an actual functioning product that can service the users.
So Alexei, do you spend most of your time looking at technologies and startups in this area?
And I'll start with a quick introduction, if you don't mind.
Sure.
I'll spend like 30 seconds of who we are and what we do. We're a venture capital firm, 100% focused on next generation ground transportation. And so our belief is connectivity, more slow, and changes in demographics and urbanization and continuous move of people from rural areas to the cities, as well as change in consumer behavior, are impacting the entire stack of how we use transportation. One, transportation is from how people choose the vehicles, how they purchase them, how they finance the purchases, how they insure those vehicles, how they put them in fleets and manage those fleets, all the way how these vehicles are built, how they're used to move people and cargo, all the way to maintenance, repair, and eventual disposal. So we believe the entire stack, about $3 trillion a year, is going through pretty rapid transformation as of right now. As a part of our portfolio, we made 13 investments. We're closing another deal this week. I'm one of co-founders of the firm. We believe that autonomy is clearly a very, very powerful force which will disrupt the ecosystem. And somewhat kind of funny, the same way as many societies jumped from not having landline phones all the way to smartphones and applications, and we know many countries and many regions of the world, which did, we believe United States is uniquely positioned to do this jump because our public transportation just sucks. And so all of you travel in Europe, all of you go to Asia, and we just don't have any public transportation. And so the problem needs to be solved somehow, and we believe that's why we are in the hotbed of autonomous driving. We need to solve the problem. And so about a third of the portfolio today is in technologies for autonomous driving, next generation startups. So we're relatively early investors in Lyft, and I will not steal your thunder, so please tell what you do or don't tell us what you do. Then we are early investors. We see that company DeepScale, which is making low-level sensor fusion, and their approach is to, instead of trying to identify objects, classify objects, and using different sensor modalities, say camera, LiDAR, and radar separately, we as human beings, we're making sense of reality from all our sensors simultaneously. We use the touch, we use the sense, we use the smell, we use our eyes, and we have a joint representation of reality. And so there is an intellectual argument that instead of trying to have separate modalities to observe and perceive reality, you need to fuse all the data together and make it happen.
So Alexei,
Yeah.
when you mentioned companies like DeepScale,
Yeah.
and you mentioned the companies that are in your portfolio doing this, do you think that the technology building blocks are largely there and the opportunities are around driving the costs down and increasing performance, but the building blocks are in place so that it becomes a software problem and a system problem as much as anything else?
Excellent question. I think if price is not an issue, and we'll go to...
Let's just take that proposition.
Okay, price is not the issue. I think sensor technology is pretty much there. If price is not the issue, I can oversaturate my test vehicle with massive amounts of extra sensors. I think compute, if I don't care about energy and footprint and how many batteries I need to carry, I think I have enough NVIDIA blades. And by the way, one of our investments is XNOR, which tries to reduce shrink and do compute on the edge, some really cool stuff, but not the issue.
Fill the trunk with NVIDIA.
Yeah, you're fine.
Okay.
I think in reality, and that's kind of scary thing about neural nets, I think neural nets is a workhorse of autonomous driving today, and all of the speakers can provide comments. The challenge is a neural net by nature is a black box, and it works until it doesn't. And so
We don't know why.
and we don't know why, and we don't know when. And so as long as society is willing to carry those limitations, and you cannot kind of debug it and reverse engineer it, you can say, oh shit, I just killed somebody in Arizona, for example, or in some other part of the world. You cannot reverse engineer it. And so the question is, what should we do with those corner cases, and how far are we from having 2 nines
I think
or
it's
4
actually
nines or 6 nines?
I think it's an interesting question because
Yeah.
I meet with a lot of companies as well in this space, and there are different approaches that people have for identifying things, and some of it's black magic, and some of it is much more deterministic. There are different approaches, philosophies that people have to it. But one of the things that I hear over and over is, how do you actually instrument a system to know when it's actually reliable enough? And one of the ways that people have that today is you have, I think it's the California DMV that requires people that are testing on the roads to report the disconnects per, what's it, mile traveled? I forget what the statistic is, Sterling.
Critical disengagements.
Critical disengagements. And you have some of these statistics that the government's starting to do, but when you take a look at this tech, whether you take the deep learning approach or the different types of sensors you use, Ivan, when you look at Zoox and the sorts of things that you're doing right now, would you agree that the tech is largely there? You can see with Moore's law how it's going to come down in price and cost very quickly. How do you develop in the meantime before it's fully commercially, I'd say the business model is there, but you know that it's coming? Like, how does that work? How does a company manage that?
Yeah, so I mean, from our perspective, this is no longer a moonshot. It really comes down to execution and kind of systems engineering. I think.
And quickly, I should have asked for what you can share about Zoox for the audience. People may not be familiar with Zoox.
Just a 30-second introduction on Zoox. Zoox is a company that's developing the full ecosystem for autonomous mobility. So what that means is we kind of see it as kind of 4 pillars. One is all the software and the core AI to drive fully autonomous, perception, planning, prediction, as well as simulation and mapping, and we're doing all of that in-house. We're also developing a vehicle ground up, and we think that's really important. The same way with the internal combustion engine came around, the right exploitation of that technology wasn't to stick it behind the horse. It was to come up with a new architecture. And so we've seen that play out in electric vehicles where if you design ground up, rather than try and stick in a battery inside an internal combustion engine vehicle, you get a lot of efficiencies and a transformative product experience. We also focused on the operating model, which is how do you deploy these vehicles, how do you service them, maintain them, clean them in cities. And lastly, we think that there's obviously a lot of investment going in the space. We think ultimately this is a technology that's going to differentiate based on product experience. And so we're designing purpose-built vehicles for autonomy and ride-sharing, which is obviously a lot for a startup to take on. And I think why are we doing that? I think you referenced Clayton Christensen, right? The innovator's dilemma, and I think we look at it as the early phase of any major technological kind of paradigm shift. It's actually the companies that are much more vertically integrated that typically have historically been more successful. And we've seen some of the challenges in partnerships and kind of bringing the different ecosystems, the pace of iteration, even the commercial kind of tensions of how do you capture, who captures how much value, and who owns the control points. Those are all pretty contentious things. So by going vertically integrated, taking on that challenge, we think we can de-risk some aspects of our roadmap, but obviously that puts more pressure on us. So like I said, Rob, I think it's no longer a moonshot. I think the architecture is there. Going back to some of the challenges, obviously sensors and compute are two things that are following cost curve, both in terms of performance and cost, but largely you can deploy with today's technology if you had to. And I think really the challenge to kind of doing this in the next couple of years is to get the system architecture and the safety design right. And so how do you test and validate that the system is, how many nines reliable? And I think that's really kind of where some of the players, including ourselves, are trying to kind of figure that out. And we can go more into that.
Yeah, well, I think the biggest question that I see as an investor in the industry, just watching what's going on and looking at it, is how much vertical integration will there be in these companies? And when you look historically at other areas of technology that have come along, you've had some players that have picked off a layer of it and done really well with that, whether it's operating system layer, and it could be applications that ride in it, versus doing the full stack. And there are some things that automakers have been very good at historically, and one of those is testing vehicles to be able to survive different environmental conditions, decades, literally for decades, and maintenance and everything that's required there. And to a certain extent, that's, as I understand it, the Aurora model, which is work with the automakers, the things that they're really good at, and help them with the software stack that they need to allow those vehicles to be able to work autonomously. And then in contrast, you have Zoox that says, hey, this is such a fundamental shift. Is it one or the other? Or it's such a fundamental shift that it needs to be full stack. We'll reimagine the vehicle as well as all the software and services to do it. Do you think that there's a world where these coexist going forward, these approaches, or is it one or the other, Sterling?
We very literally coexist right now.
I agree.
I think I have
Short period
tremendous
of time.
respect for what Zoox is doing. One of the things that I'll say is the vehicles that we drive today, that humans drive, have a common set of interfaces, right? They're all designed around the human driver. They have an ignition approach that you can use. They have a steering wheel, they have a brake and a throttle pedal, in some cases a clutch. We designed these specifically for a human driver. An autonomous vehicle, I want to dispel the notion that there's something magical about the vehicle itself when it's autonomous. There's not. There's a different set of interfaces, there's a different set of requirements. There are additional redundancies that are required. But at the end of the day, the interface for autonomy is just a different form of the interface we've designed around a human driver. And so what that allows is a company who's building a platform that the entire industry can use. Right? Right now, 2 of the top 3 automakers in the world are designing platforms around Aurora's stack. But what that allows you to do is establish, this is the interface requirement, right? Specifically, we need access on CAN to the following telemetry signals. We need to command over CAN the following controls. We need these actuator limits. We need those.
For people that aren't familiar with CAN, what's CAN?
It's a communication protocol that's used in a lot of vehicles. So we need access to these things, and so you establish that interface just like you would establish an interface for, look, the average driver is between 4'0" and 8'7", right? Those are probably wrong numbers. But you establish sort of what those requirements are. You build the safety case together, but then you establish the perimeter of the product, which is to say, look, if you want access to Aurora's technology, we're going to be focused exclusively on one product. And what that allows you to do is leverage the scale of all of your peers who are also using that product, right? Every mile that's driven with Aurora's stack, and by the way, we do more than just the software, we also do the hardware for it, right? So you want to run Aurora's stack, you design a vehicle with the interfaces that we've specified, with the hardware that we've designed, that will work into the standard Tier 1 process, because again, just like OEMs are very, very good at producing the vehicles, Tier 1s in the supply community have for years honed this ability to crank out at extraordinarily high volumes and low costs very reliable parts and hold them on the shelves for 15 years. Our ambition is not to manufacture these parts, but instead to design them and ensure their specifications meet the requirements of the self-driving system. But I guess the point I'll make is establishing the perimeter of the product allows one, and doing that carefully and thoughtfully, allows one to integrate with a wide array of ecosystem. And then establishing on the back end the APIs to connect with a company or service like Lyft, to connect with a service like Uber or like Didi, allows at the same time this sort of consortium of everyone who's unified around this core product to put it into services that already exist and are already established. And that's part of the model. And I'm not saying this to contrast specifically to what Zoox is doing. I'm saying this specifically as this is why we're doing what we're doing.
So from where I sit, one of the observations that I've had in companies that are building autonomous vehicles and working their way up the stack to layer 4, layer 5, I've gone on a lot of test rides. with different companies. And some of those test rides, candidly, can be somewhat, I wouldn't say nerve-wracking, but a little bit unsettling because you have somebody in the driver's seat who's ready to take control at any moment. And I think to myself, that's got to be one of the toughest jobs you could possibly have, is to be a safety driver. And there's actually places that you go to learn to be a safety driver. There's actually schools for safety drivers because you have so many cars that are out there. How do you know, and at what point, and this is an open question to people on the panel, at what point will you see the first cars that are operated on public highways without a safety driver inside? Like, what has to happen to allow that to actually unfold?
I can, but just before I answer the question, I just want to make sure I put Lyft a little bit more in context because, so as you guys know, Lyft is, a rideshare network. We're in the business of building out a transportation network to get people from A to B. Clearly for us, we have been investing quite a lot on autonomous, and the approach we have been taking here really is a two-pronged approach. One where we open up a network, so folks who are actually building an autonomous car can plug the car into a network and then be able to actually service rides today. You can actually take a autonomous vehicle on the Lyft network today, thanks to our partner Aptiv in Las Vegas. Right? And the other aspect of that really is we are also working to build out the entire technology stack on the autonomous side, which is what we're calling the level 5 effort. And we are right down here in Palo Alto with all of the layers on perception autonomy and so on and so forth. Right? And going back to your question about the safety driver piece of it, I do believe that for a very long time we're going to have a safety driver in place. But the way in which I think we would get to a point where we would get the driver out of the thing is by doing systematic validation, right? And a large part of the validation is exactly in the context, of knowing what your geography is, what your domain really is, right? By narrowing down your domain, you get to a point where you're able to get a better handle on what is it the car encounters, and that is what becomes a stepping stone for you to start contemplating getting the driver out of the driver's seat.
And very quick question, when you talk about the Las Vegas rides you can get today, does that have a safety driver in the car? Okay.
Yeah, and Rob, I'd like to jump on your question. I know three of you guys represent more or less passenger cars, but I think commercial vehicles and trucks are a somewhat different beast. And if we see certain crossover regime in passenger cars, I think crossover regime in commercial vehicles is totally different. And you may know kids don't want to go and drive commercial vehicles. Everyone is okay to jump as a Lyft driver and drive for a couple hours a day, but commercial drivers are in a very short supply. And so even with safety drivers, so strangely enough, if you don't steer the vehicle, according to regulations, you're not driving in the United States. And so the driver who sits and does nothing and watch Netflix suddenly can work, instead of 8 hours per day, they can work 12 or 16-hour shifts, as long as they don't touch the steering wheel. And so I think we'll see many cases where the safety driving behind the wheel will have a pretty profound economic impact to allow early introduction of level 4-ish going into level 3-ish, 5-ish kind of vehicles. But it may be commercial side first.
A couple of things. One is you may see up here, you can text questions that you have to 650-308-8522. In about 20 minutes, 15, 20 minutes, we'll start taking questions from the audience. So if you do have a question and it occurs to you now, be sure to text it to that number and we'll be able to go through those. Ivan.
Yeah, you've been trying to get at this question. So our view is, in terms of fully autonomous cars, the way that this technology is going to roll out, it's going to be in a ride-sharing application, and to Vinay's point, it's going to be within limited kind of operating design domains or geofences, so to speak. I think even within that, why ride-sharing? Because frankly, the cost of these vehicles is still quite high to sell it to a consumer, and there's a lot more money and a lot more profit to be made by deploying them in the ride-sharing applications. Then within the operating design domain, I think there's different players tackling different levels of complexity. Some people are doing kind of campus shuttles, which is relatively very low speed, very low complexity. And other players are thinking of operating the entire city. Right? And in that case, you could cover most kind of point-to-point ride-sharing trips today. I mean, the average ride-sharing trip is roughly 15 minutes and 3 miles or so. And so as you think about creating a geofence, it's going to be within a city. And I think the big advantage of that is, once again, it's focus. If you're a mobile eye and you want to sell your technology to BMW or whatever, and BMW sells on all 5 continents, that's a different problem to solve than if you're saying, hey, I'm going to start out in one city, I'm going to conquer one city at a time. And I think that's an important distinction.
I think one of the things for people that are coming up to speed with what's happening in AVs today versus a year ago, versus 2 years ago, versus 3 years ago, is there's a common theme that actually the technology permits it today. And what everybody is really thinking about on the business side is how does the market unfold, and how do startups go to market in a time frame where they can make enough money to justify the capital that's going into the companies. So what that means in practice is there's kind of a bridge of whether it's teleoperation or whether it's limiting the problem to a very constrained problem in campuses or cities, et cetera. I think there's a lot of agreement along that. Go ahead.
Can I make one point? So I just want to impress on everyone. I think when we hear numbers like 1.3 million people dying on our roadways every year globally, or numbers like 40,000 in the United States, one gets the impression that, wow, there is so much opportunity here. How could you, this seems like such low-hanging fruit to pick. I want to impress on everyone a little bit the real complexity of this problem, which may seem mundane to you as you've been driving for many years, but is in fact very much not, right? So take this on a vehicle level rather than a population basis, right? On a vehicle level, every year in the United States, I think it's something like 88 million miles, or 88 million miles between deaths, right? That would be...
That's a very large number.
That's a very large number, right? So you assume for a moment that is that
How
the
many
average...
ladders to the moon is that?
I don't know. But the average the average American drives, what, 13,000 miles per year?
Sounds about right.
So that puts us at 6,700 years, right? 65-year average driving life, and we're talking 104, just over 100 lifetimes between deaths, right? You take accidents alone, and I think Insurance Institute numbers suggest that one happens on average every, call it 18 years of a driver's life. 18 years. You drive 250,000 plus miles in 18 years. The car does not get in an accident for 250,000 miles, right? So look at it that way, and it's an extraordinarily complex problem. And when you think about the fact that even take a situation that you or I would consider relatively simple, right? We're at an intersection. We've got another vehicle here. We've got a bike there. We've got a pedestrian here. As you game out what you're about to do, you're thinking, if that vehicle, based on where that driver is looking, what he seems to be focusing on, and how his vehicle seems to be moving, I think this pedestrian is going to react that way. And because the pedestrian acts this way, I think the bicyclist is going to react this other way.
Yeah.
And based on how I game out the various scenarios, I'm going to behave this way. But turns out, if I behave a different way, they're all going to act different. And this scenario is going to play out entirely differently.
Recursive.
Right? These things are things that go through sort of the neural network in your head as you're driving based on your deep understanding of human behavior and human psychology and how different actors behave and how you expect them to behave. This is just a small taste of the kind of complexity that you have to deal with if you want to drive 250,000 miles before you have a single incident. Or if you want to drive 104 lifetimes before you have the first death.
And you've got to be 10x better than that.
And how about
You've got to be
international
better.
development? So in some countries, people cross the streets at the right time in the right place. Do you think they will be first adopters or?
No, and this is, as Ivan mentioned, it's, I think it's critical that you down select to a set of operational design domains in which you're confident. And gaining that confidence is a combination of various things to include both empirical sort of on-road evaluation, but also simulation and other ways of sort of permuting those scenarios and getting confidence in them.
So I think that brings up a topic that I've been very interested in recently, and I think people will become increasingly interested in, is the topic of simulation. And about a year and a half ago, I went down to NVIDIA's demo center for the first time, and they have a series of things that they show. One of them is a TV screen, and one is an actual parking lot, and another is a simulation of that parking lot, Grand Theft Auto style. And you look at the two, and you navigate the two, and to a human, it's impossible to tell the difference between the two. When you look at the shading, when you look at the textures on the cars, when you look at the behavior of how they interact. So you get to a point where you can actually spend money on computation to do simulation and to do the lifetimes of driving. I think the complexity becomes how much of the psychology are you able to actually put into that to emulate or simulate what humans would actually do when they're operating vehicles. So the question that I have for the panel is, how important is simulation going to be, number one, in developing and testing the routines? And how important is simulation going to be to regulators saying to companies, you need to do thousands or millions of miles on this standardized program to be able to certify vehicles?
Who's that for?
Anybody, jump in.
I can get started, but please guys jump in as well. So I think simulation is incredibly important, but it's also important to think of it as it's one of multiple tools that you have to test and validate and ultimately certify a vehicle. Other tools are obviously like real-world driving, structured testing, log testing, and so on. So on the topic of simulation, yeah, I think there's kind of, if you think of the autonomous system as two parts, one part is perception, which is kind of the sensor systems and the vision. The other part is the planning system. You can do simulation either on the planning side, or you can do both planning and perception. So the photorealistic aspect of simulation is incredibly important because that's 50% of your software stack. And so you want to get photorealistic images for the camera visions. You want to simulate LiDAR and radar and all of those things. And you also want to have accurate material properties. So the way a LiDAR reflects off a black vehicle versus like glass versus whatever. So it's actually, it ends up being a pretty complex system to develop.
Simulation system, you mean?
Simulation system.
Because it could look like Grand Theft Auto, where you see people running around, but it's not LiDAR compliant. Like you gotta
make it realistic, and you gotta be, and then you gotta. The real value of simulation is, it's not really about miles driven, because you could just run a simulator driving at 70 miles an hour on a straight line. It's really around creating different scenarios, injecting, kind of different agents, different behaviors, what's called fuzzing. And that is one aspect where you can, every time you change your code, you can rerun that set of test cases and kind of categorize how your software stack is performing. Of course, you have to couple that with real-world testing and structured testing as well. So I don't know if you guys want to add a little bit more to that.
Yeah, I agree. I think simulation is a critical piece of autonomy. I think to Ivan's point, the key aspect there is exposing your software to a diversity of scenarios, basically. That's the piece that Sterling was talking about as well. It is that diversity of exposure that ultimately allows you to get to a point where you feel confident that it actually functions in that envelope. Right? With respect to the sensor-based testing, and I want to see if you guys disagree with this stuff. It feels like the imagery-based sensing, is not necessarily very representative of the real world. No matter how photorealistic you really end up getting, it still doesn't feel like it truly captures the noise characteristics of real sensors, right? But higher level, if you're talking about actions, you're talking about the way agents interact. There's still ways in which you can simulate that in a way that's actually useful for the software stack.
We spend a lot of time thinking on this particular topic. Yeah. And so for us, what photorealistic for us is different for the computer vision.
Humans.
Yeah, and as you said, exactly.
Okay.
Vehicles are designed with human UI in mind, but if you are designing self-driving stack, and if the self-driving stack can rely on different sensing modalities. Okay, we can see only in visual light, but how about infrared? How about radar? We don't have radars around here. We don't have LiDARs. All we do, we have eyes, essentially, and a little bit of accelerometer to drive. And so once you start moving in those additional sensor modalities, photorealistic is not enough. And what we're observing is surprisingly challenging problem. especially on multi-path radar reflection and some other technicalities. But it's a super critical piece to get to autonomy. And I think the fact that I think governments at some point will step in and say, you know what, we have our standard scenario benchmarks, and we programmed our like 10,000 corner cases, and so we want to test your algorithm against our 10,000 corner cases, and if it can pass up to a certain point, you're allowed to do road testing. I think it will be the future, but clearly very important part.
So what do you think, and this is an open question, especially to the people building the full stack solutions here, has to happen in the regulatory environment for governments to sign off and allow cars to operate without safety drivers, and for that to happen in any sort of meaningful volume beyond a few vehicles per fleet? What has to happen? At what point do regulators feel comfortable enough to allow that to happen?
I would say we're fortunate. We have Anthony Fox, who is the former Secretary of Transportation, U.S. Secretary of Transportation, is our advisor, and we're talking to him on a regular basis, say once a week. And so it looks like at least current administration is very relaxed about regulating autonomous vehicles. And whether it's good or bad, I think it depends on your point of view and if you're in the business of building those vehicles or not building those vehicles. And so the way we see it, we'll have a lot of regulations in the next couple of years on the state level, but at least federals will keep their hands off. And who knows what will happen during the next administration. Another interesting rumor we heard, and maybe you guys, Zooks and Lyft, tell us, there is a notion of if you have enough vehicles on the road, they will be grandfathered by the next administration. And it's one of the reasons people are just trying to dump vehicles on the road, even if they are not perfect. But just to have them now and to say we have a fleet and see what will happen during the next administration on the federal level.
Yeah, it's interesting when you think about regulation, because in a lot of ways, to enable the industry to move forward, having legislation that defines when vehicles have been certified, et cetera, is extremely important, because putting aside any of the full stack companies, when you think about people that are building systems that might be optimized for identifying objects, so classifiers, or people that are building different parts of the stack, how do you decide, well, that happened because somebody misclassified something? You really need to have standards that allow the safety, because going back to some of the things that Sterling was talking about, at some point, it's very clear that these vehicles are going to save lives. There's definitely a public good in doing it. And I think regulation in a lot of ways, together with industry, is going to be one of the things that unlocks these vehicles to get out on the road. So I have probably one more question for the panel before we go to the audience question. I have some great questions that are coming in from the audience, but I want to encourage people again to text questions to the number up here, and we're going to start going through those questions. So one last question that I have, and this is actually inspired by an audience question, is when these cars, and this is probably a layup for Zooks, when these cars become fully self-driving, how will automakers differentiate their products from each other? How will Volkswagen and BMW and Ford say you should buy our car or use our car versus somebody else's?
You want him to do the layup, or you want me to do one?
Let's start with, we can save the layup for later.
This is actually a layup, I think, for anybody in this space. And the reason is, if at the end of the day we're differentiating on the safety of the self-driving system, we've failed, right? That's right. I cannot go to an OEM and say, look, my self-driving system will kill your drivers 10% less of the time than his. Right? It just won't work, right? That's not how this works. At the end of the day, if we do our job right, the driver, in spite of it being one of the most complex pieces of the system that we've developed, should fade into the background. When you get on a 787, you typically don't care that you're on a 787. You care that your Wi-Fi doesn't work, right? You care that the screen in front of you has a dead pixel in it, right? You care about the experience. And our ability, or the ability of the community, to build an exceptional experience around these cars, which is much more than just the car, right? It's the services, It's the sort of integration with your everyday life. But for an automaker interested in playing in this space, the opportunity is I can really differentiate and do some magical things with the inside of my car. So one of our partners, a company by the name of Byton, is building a new car sort of from the ground up around a combination of this stack and some other interesting things they're looking at. One of those things, as they announced in January, is a set of displays that create this sort of immersive environment. Right? And when no one has to drive, or when you get to be ferried sort of around in one of these cars, you can do a lot of really interesting things with that environment. And you can create, Volkswagen has talked about some of the incredible things that they're interested in doing with the Cedric and some of the other custom-built vehicles that they're producing. And so the opportunity to really differentiate is not going to be in the driver, right? It's going to be in the services around it. And autonomy is really going to unlock the opportunity to do that.
Do some automakers have more trouble with this than others because you think of BMW being the ultimate driving machine?
I think many of them acknowledge this, right? I think many of them realize that analog brakes, nobody cares that you have analog brakes in your car because every car has analog brakes. The stability control systems, anyone who did that in-house hoping for it to be a differentiator, at this point probably appreciates and understands that's no longer a differentiator and not a source of sustained competitive advantage. And so I think much of the automotive community recognizes that the opportunity to differentiate lies not in the quality of the driver, because that you meet a certain threshold where it's good enough, it's safe enough, and then from there the game is not that driver. The game is the experiences and the services you can build around it.
Yeah, so I agree with what Sterling said. Couple of thoughts. One is it's obviously a massive market today, and we've seen current iterations of autonomous vehicles on the road, and even if there's no safety driver, you see the steering wheel kind of turn around, and you can't help but think that's just not what the future is going to look like. I'll give you one example. Imagine it's a ride-sharing car, and someone gets out, and the customer forgets to close the door. What do? You accelerate to try and close the door? Doesn't sound very safe. So I think we are going to see segmentation in the market. We are going to see differentiation. People often assume that point-to-point mobility is a commodity, and it's just about getting there at the right price and on the right time. But there is people that will pay a premium for a great experience, and there's people that just want the lowest price. And so I also see the car will become obviously much more than just getting people from point to point. And I think that's what we at Zoox started out with that. What is the full realization of autonomous technology? And if we can imagine that, how do we get there? Not 10 years from now, but how do we actually start building it?
So I have a follow-up question on this, because people do like to talk a lot about the user experience and the ride experience, what it means to get in, et cetera, and that feeling. We have Lyft here, the incumbent, and Lyft is the company of the pink mustache and the ride experience relative to Uber, which it took Uber years to decide to allow people to tip drivers. And Lyft had that type of thing. So it wasn't just the rider experience, but it was the driver experience as well. What do you think people miss when they talk about the idea of the user experience when it comes to getting a ride from one place to another?
Well, first of all, just touching upon the points that Sterling and Ivan made, I think technology has been disrupting several industries by converting into a service model, right? I mean, if you think about what Netflix has done, for instance, you stream movies now. You don't buy DVDs anymore. With Spotify, you stream music. You don't purchase MP3s anymore. And I think ultimate transportation is ultimately going to get disrupted by autonomy by converting the whole transportation sector into a service model. So we spend about $9,000 a year owning cars today, and I think ultimately what's going to happen is that hopefully with Lyft, you'll end up subscribing to a transportation as a service, and when you want, a car's going to come and pick you up. And in that experience, sure, there's going to be striations in terms of the experience. You'll have a base experience, you'll have a premium experience, and so on and so forth. But at the end of the day, it's going to be a service that you invoke and you get the customer.
Will people be able to get the equivalent of Amazon Prime? Will there be a Lyft Prime?
Possibly, yes.
Okay. So a question for the investor on the end here. Are you long or short automotive insurance?
Ooh, we just actually, Yeah,
Long or short?
short.
How short are you?
We are actually long short. We just invested, we seeded insurance company specifically to benefit from all the technological innovations coming into automotive space. And so the way we see insurance evolving, incumbents are having really hard time adjusting to the new realities, whether it's car sharing, whether it's just asset sharing like RV sharing or TNCs like Lyft. I think they're falling behind. And there are reasons to believe you can disrupt the industry in a pretty massive way if you do things right. And so we are short incumbents, we're long new startups with a different philosophy.
So there's another question that came in from the audience, and I think of this as the trolley car problem. I think everybody on this panel, if you've done an AV panel, has been the trolley car problem. I think probably Ivan could even say the question, which is, how does a car make a decision in an impossible situation, who might get hurt and who doesn't?
You're the product guy, right?
Yeah, this comes up at every one. Can I just do the same thing I've done in what feels like hundreds of forums where this comes up? Raise your hand if you've ever had this experience or know someone who has. You had to decide between killing one person and killing someone else. Okay, let's move on.
Okay, I'm fine with that.
I don't mean to be facetious about this, but if you get yourself in a situation where you are literally deciding between taking one life and taking another, you've probably done something wrong, right? So you're driving on a cliffside with visibility of 50 meters through the fog, and you have some reasonable expectation there may be a child playing on said road. Don't be driving 70 miles an hour, right? There are things that you do to sort of minimize the likelihood of getting into this situation. I will someday, if I ever ask that question, I get someone to raise their hand, I will be very surprised.
So the one comment I would add to this is, when you talk to the ethicists and people that are looking at it right now, they say, actually, what's interesting about the question, and they've done studies on this, is if you do make a dumb mistake and you're in a location, in the situation where you say, is it my life or somebody else outside the car, subconsciously people tend to make decisions, whether they realize it or not, to preserve themselves. And it's kind of an interesting question over time to see how that unfolds. The car, in some ways, could be a lot more dispassionate about what to do.
I think it's very culture specific, what you just told. And no, seriously, I heard from several people that Google did research a long time ago, and they found in certain parts of the country, if you ask to rate, so you have three options. Autonomous car will hit obstacle, and it will be moving car, it will be the tree, or it will be a person. So clearly for a driver, person is the least dangerous thing, and tree is the most dangerous thing. And they ask people across countries, rate number one, number two, number three. In some regions of the world, people say, okay, my first preference is hit the tree, so I'm jeopardizing my life. In other regions of the world, people say, I prefer to hit a person to reduce risk for myself. I think it's very culture specific, even in the US.
So another audience question here is, self-driving vehicle prototypes are very sensor heavy today, and you see it in a lot of cars that are out there. You see LiDARs hanging off of every appendage, you see RGB cameras pointed every direction, radar, et cetera. You might see cars where you have easily $100,000 worth of sensor equipment. Is there a tipping point that sensor equipment, if you just think about it as part of the bill of materials, the BOM of the vehicle, for it to get to either as a percentage or just a raw cost to where you can get to the deployment of a fully autonomous vehicle and have it make economic sense?
I mean, even today with ride-hailing, if you look at the economics of how much revenue these vehicles can generate at what margins, there is a payback that would justify that type of investment today, right? At UberX pricing or Lyft, right?
Can we talk some numbers for a second?
But
so he threw out $100,000, right? Average ride-sharing car is doing what, 70,000 miles a year? Ish. 5-year useful life, 30 cents per mile, amortizing that cost. Is that right?
It's a lot more than 30 cents a mile, I can promise you that. If you look at it today in terms of, the average ride sharing, once again, it's downtown. I mean, just to get into a Uber in downtown SF, you're paying like $3 before you've even driven.
I'm actually validating what you were just suggesting.
Thank you.
Well,
the amortized cost of the hardware,
Yeah.
given the number that he just threw out there, 30 cents per mile, you're paying, there's a margin of what, $1 to $2 in a lot of urban centers of margin that you're playing with. So you're profitable already if you put this. So you remove the driver, and you've just unlocked, $1 to $2 per mile, and you've paid 30 cents per mile in
It's an
hardware.
interesting question, because if you can do it with $100,000 worth of sensors, are you going to want to get in the car that has the best sensors? So is that a point of
Well, let me-
differentiation? You want to get in the car that has twice as many sensors on the
Let me
roof?
put it this way. I think today, right, going back to safety, you are better off over-provisioning on sensors, both for redundancy and for a lot of, frankly, corner cases, right? So we've done a lot of deep work on understanding what are all those corner cases. And despite what some companies in building lots of cars in the Bay Area will tell you, one radar and 1 or 6 cameras and a couple ultrasonic sensors will not get you there.
Cameras.
Right? So you do have to over-provision, and the cost of that over-provision, you can optimize the system later on in time once you've kind of really figured
Software
out.
upgrades?
Oh, no, you can decontent. It's much easier to pull sensors off than to realize, I've got 1,000 vehicles in deployment, and I'm missing 2 cameras because I've got blind spots for this corner case.
So Ivan's exactly right, and I want to pile onto this, and I'm agreeing with you. What made a particular electric vehicle company successful early on was building cars that, while expensive, were spec'd up with enough hardware to create a great experience, right? And then over time, bringing that cost down and working towards more mass market products. Self-driving is the same way, and I think Ivan and I see eye to eye on this. If you want to get to market soon, the best thing you can do is provision for the kinds of redundancies that allow you to do that. And having redundancy on multiple modalities of sensors, from radar to LiDAR to camera, with 360 degrees of azimuthal visibility and coverage, allows you to come to market more quickly with a safe, reliable system that over time will either A, cost down as the volumes of those sensors increase in production, or B, decontent as you are validating the system with fewer and fewer sensors. So I agree, that's absolutely the right way to approach this.
In a lot of ways, it's the beauty of the free market, right? Because it'll either become a more effective car with more sensors over time. It'll come to some solution, and companies will take slightly different approaches to get there. So when you get into these cars, so let's imagine getting into a Zoox vehicle, and I think of the ultimate self-driving car as something that it's like getting into an elevator. You push the button for where you want to go, and it's incredibly reliable. You think about elevators. How many people actually in this room have ever gotten stuck in an elevator? Raise your hand. Oh, that many. Oh. Holy cow. How many haven't? Okay. So when you think about all that, and for the people that have gotten stuck in an elevator, how many people have gotten stuck in 2 different elevators 2 different times? Okay. Oh, jeez. All right, I don't want to fly with any of you guys, ever. So when you get in the car, think about when you get in the elevator, you push the button, the doors close, and then nothing happens. And you're on the 40th floor, and at least for me, there's this moment where you have kind of this panic curve that starts coming along. So when you get in the car, what kind of feedback are you going to get from a fully autonomous car to share with you what's going on? Any?
What do you mean by feedback? You mean like?
Well, if the car is sitting there after you get in and just kind of hanging out, or will the car communicate with a rider what's going on?
I mean,
And how does, if you can share, how does Zoox think about that, or how do designers think about these types of UI questions?
Well, I can't share specifics, but the same way as you get into an elevator, right? You have a little red button there that calls an operator. Like that's a hint, right? So then
You hope the light's still on in the elevator when you have to push
and
that button.
you've got your app, you've got maybe a screen in the car or something like that. So I mean, part of this differentiation on product experience is how do you make customers feel safe and comfortable, and how do you communicate? You know, potentially maybe there's a failure, maybe there's a construction zone or something, or maybe you enter a degraded mode of performance, and you have to pull over on the side of the road, and how do you communicate with the customers during those moments so that they're not kind of freaking out? And that's all part of how you design not just the technology, but also the entire product experience, and going back to what Vinay is trying to do, how you got to get people A to B reliably and safely and comfortably.
And I think longer term, it won't matter so much. I think what's going to happen is that at some point in time in the future, it's going to become so normal of an experience that it
Like an elevator.
Like an elevator. Get in the car and it gets you to where it gets to, right? Of course, assuming that we get to those milestones. Right?
So here's a question that I love. How will this affect auto racing?
Well, you've got Robo Race now, don't you? Kind of.
I think sometimes when people follow F1 or you follow IndyCar, it's about the personalities of the drivers as much as it is. It's like watching sports. I mean, it is a
horse
sport.
racing as
Yeah,
well.
horse racing
Horse
is a good
racing.
analogy.
I do think that's the direction it's going. I think it's actually, you'll see level 0, level 1. But a lot of the most interesting racing, and I race for fun, just amateur club racing now. The cars I like to drive are the ones that don't even have anti-lock brakes. You actually need to have skill to drive and operate the vehicle. So I think horse racing is a good analogy, unless any of you guys.
You're safe. I think you'll be able to continue.
Still
your
have a roll
passion.
cage, though. Yeah, yeah. I do think the one thing that it would have is you would probably have safety systems that would be watching in case something really spectacularly bad is about to happen. So whose insurance pays with 2 AV autonomous vehicles that get into an accident? Who pays?
Liability is in an active topic for the industry. I think it hasn't yet been sorted out. Some just high-level guidance on this. The good news is we got a lot more information about what happened when we have autonomous vehicles. And so establishing fault is a little bit easier. Establishing who is then responsible for that fault is a little bit more tricky. So I think it's not yet concluded.
And I think that the biggest question is it car OEM who launched the car, is it one of operators like TNC's, Zooks, and Lyft's? Is it part of somebody who produced the brain for the vehicle? Who will be liable in the end? I think the jury is still out.
Yeah, for us, it's, I think, relatively more straightforward because we're both developing the software and the vehicle itself. Presumably most of the time we will not be at fault, right? But let's say there's a scenario where Zoox is at fault, then we would bear that liability, right? Because we can't point fingers, and that's one of the challenges I think also with partnerships is how to think about risk sharing and throughout. Yeah, I mean it's no different. Like with Takata, is it GM on the hook? Is it Takata? Like there's quite a lot of product liability, and kind of tracing that to the root cause is going to be, I think, one of the, as Sterling said, something that needs to get figured out.
It's interesting as any market evolves, you start to think about questions you hadn't even thought of up front. And one of them is this question we were just talking about now. And somebody said, what about speeding tickets? Who pays a speeding ticket or a red light camera ticket? One thing that I think is going to happen is when you think about high-speed rail in different countries, and I think earlier people were talking about the US might have a competitive advantage because our public transit infrastructure is behind. It's more important to deploy autonomous vehicles. You could imagine in California, you just build, say, 2 to 3 more lanes down the middle of the 5 to go to LA. And even in the interim, you say this is purely for level 4 vehicles, and you let cars drive down them autonomously at 150 miles an hour. You have an infrastructure that's a hell of a lot cheaper to build than high-speed rail, and you have the benefit of once you get to Los Angeles, you can drop those passengers off where they want to go. So are there any other unintended or maybe non-obvious scenarios that each of the panelists see? We're getting towards the closing minutes here, but people don't see in the future of autonomous transportation when we get to fully autonomous vehicles that's going to happen in about 10 or 15 years. That's not part of the conventional wisdom today. Maybe start with the investor because, Alexei, because you get paid to think about the far future.
I think we will see much faster deployment in commercial vehicles, partial autonomy than people realize. There are many economical reasons for that, and by the way, they can pay $100,000 to $200,000 for sensors. It's a very small amount comparing to the ASPs of those vehicles. And I think we'll see some countries, Singapore is clearly one of them, where you can essentially treat the entire country as geo-fenced location, and you can enforce additional layers. And we didn't talk about kind of smart infrastructure. So vehicles in the States, they tend to be self-dependent because we don't see governments and cities investing in smart infrastructures. But in some other regions of the world, they can oversaturate roads and everything else with additional sensors to make easier for autonomous cars to navigate and plan their trajectories. And so I think we'll see autonomous driving no matter what in 10 years. It's just a question which vehicle classes, which use cases, and which geographies.
Yeah, I think infrastructure is hard. I think expecting to build out those extra 2 lanes on I-5 is not trivial by any means, right? And so I think, to Ivan's point earlier, with autonomy, at least as of now, it does feel like it's a tractable problem in that we put in enough time, we put in enough effort, and at least define a certain operational domain, and within that operational domain, we can crack that nut, right? If that statement is true, then we don't need that heavy investment in infrastructure to enable this stuff. What might actually make more sense, now we might have to go down that route if after spending enough time collectively all across companies, we decide that, hey, there's something fundamentally hard about this problem that we cannot solve it. At that point, it would make sense to go down that piece. But right now, it feels like, we probably don't want to have 2 more lanes on I-5 to enable this stuff.
I think the clear answer is tunnels.
Tunnels.
I think that's what everybody's missing.
That's boring.
I mean, I think in some ways it's such a captivating topic that the futurists and the imagination has, almost everything's been written that could happen, and really I think the focus is what can we do in the next couple of years to start this, and I think that is very, very real of getting autonomous, electric, and shared in a ride-sharing model in a couple of cities, city by city, and I think ultimately, it's about safety, it's about solving congestion, green mobility, and making the mobility experience wonderful again. And I think we can do that, and it's going to happen city by city. It's not going to happen everywhere, and I think that's something that I'm personally very much looking forward to.
Any thoughts, Sterling, or is it all proprietary?
No, I think I agree with what's been said, right? I think it's not clear to me that the general public appreciates how much this will change your life, right? I think it'll be very, very gradual. I think, the most common question that I get is how soon will self-driving vehicles be here, is the statement. It's going to be more gradual than that, where it's going to be very dependent on where here is, whether it's Phoenix, Arizona, or somewhere else. But 20, 30 years from now, I'm very much looking forward to when my grandchildren ask me, hey, what'd you do to change my world? Saying this, the world that you know, because it is the way it is, because a set of people from Zoox to Lyft to others who are working on this put a lot of their heart and soul into solving this problem. So I'm excited about that.
Yeah, likewise.
Yeah, I think it's an exciting future we all really look forward to. Even people that like to drive, there will be plenty of opportunities to drive for at least the next 20, 30 years. And our kids won't need to get driver's licenses. So what impact, one final question, looking towards the future, kind of building on this, For the people in this room, when you think about audience members that might be starting companies, thinking about joining companies, they're just interested in this area, what advice do you have for people as they think about kind of their careers, or they think about companies that they want to start, where the opportunities are, where they should be building skills if they're passionate about this category?
I'll start. Jump in, the water's fine. There's a lot of, this is an extraordinarily intricate problem to solve. For an engineer who is excited about sort of changing the world, there are few problems this complex and fulfilling. And so I think it's a super exciting space from that regard. I think I would encourage thinking about what you want to, when your career is done, what do you want to have been known for? What do you want to have changed? What do you want to be able to tell your grandchildren you did to make their world a better place? I think there are a lot of opportunities outside of self-driving that could lead to a very fulfilling career on that dimension. So I don't claim that this industry has all the answers for it, but I think it certainly provides a phenomenal opportunry.
From my side, I think this is it's really a very large ecosystem. So, 3 years ago, it was, pretty much if you didn't have an engineering background, like very specific skill set, it was all about R&D. I was one of the lucky few people that was able to get a business role at Zoox. And it's been incredibly fulfilling. And there were very few business roles. I think today we're on the cusp of that starting to change. We're starting to, it's starting to become more operational. So there's a broader set of skill sets that are being brought into the business. I mean, there's still obviously, a lot of gaps to fill on kind of the core machine learning, AI, computer science, et cetera. But there's also, roles that we're hiring for, service technicians, kind of operational people, finance, et cetera. And so I think that the key is really to kind of figure out what you're passionate about, and then just also do some homework. I think there's still more engineering roles than business roles. So if whatever you're doing, get deep in the technology and understand a little bit more about what you're talking about. And I think there's enough demand there to kind of create opportunities for people.
I definitely agree with that. I think there's a lot of still hard, unsolved problems on the technology side.
Yeah.
So coming from the technology side, I would say that definitely dig deeper on the tech. I think kind of bringing that expertise to bear to solve this problem in innovative ways would be critical, I think, for all of us going forward.
And my advice would be, it's a huge industry. It's enormous industry. It's probably second or third largest industry on the face of Earth. And it's going through very rapid, truly tectonic shift. And I think the jury's still out. We're still living through Cambrian period. People are creating a lot of different permutations of technology, solutions, services. And I'm afraid, or it's a good thing, but 10 years from now, the winners will be pretty much clear. And this is the stack which won the competition. This is the business model. This is the OEM. This is how people pay for their mobilities. But for the next 10 years, it will be very rapidly changing, very dynamic, and I think super exciting area. And so I would encourage you to jump in and see how it goes.
Yeah, I mean, it's an exciting area. It's impacting $1 trillion industry, transportation. It's crazy how big the industry is. And in closing, a couple of things. One, we'd like to thank our panelists for joining us. And anyhow, also wanted to say thanks to the audience. This has actually been a very engaged audience. It's been really nice to see, and thanks to VLab for having us. And please join me in thanking the panelists for joining us tonight. All right, thank you.
Thank you so much, Rob.